Okay, so I'm going to talk about Coccinelle. Coccinelle is a program transformation and matching tool. It was originally developed for C code. Coccinelle has been, for C, has been under development for over 15 years. At this point, it's a pretty mature piece of software. It has been used extensively on the Linux kernel, and it's used on other C projects as well. So I'm here presenting it at this event because we are now with my colleague Michele Martone. We are working on extending Coccinelle to C++. So we are leveraging what has been done for C. So it inherits all of the mature features for C, but we're adding C++ features. Um, so what is Coccinelle? Coccinelle's we're basically in the same space as tools such as find bugs in Coverity on the one hand, as well as linting tools like Clang Tidy and other tools that exist for other languages. Um, so basically, the idea of Coccinelle is to help you whenever you want to find some kind of pattern in your code. It helps you find that pattern, and it also allows you to transform that pattern. So a big difference as compared to the other tools that I described is that Coccinelle allows you to actually write the patterns that you would like to find by yourself. So you can make your own bug finding rules, your own transformation rules. So in particular, in the context of C++, we're interested in modernizing high performance computing code. So we can think about code that has been evolving by hand for many years. There may be some new libraries that we want to use, some new coding strategies, and so on. And so the idea of Coccinelle is to help developers do these things easily by themselves. So in terms of the technicality, the idea of Coccinelle is to provide a user-friendly notation for describing transformations. So this notation is based on the standard patch syntax. So if you think about what you see when you look at a git log or git diff and so on, you see some basically a little extract of your software, and you see some lines of code that have been indicated to be removed with a minus at the beginning of the line, and it indicated to be added with a plus in front of the line. So the idea of Coccinelle is to take exactly that notation, where we have fragments of code and we have minus and plus, and allow it to be more general. Patches apply that we see with the minus and plus. We see those apply to only a specific place in a piece of software. Coccinelle provides that notation, but allows it to be generalized somewhat so that it can apply across an entire code base. So I have just one small example here that I would like to share. We have this poster in the poster session, and so you can come and study the other examples after the talk if you have time. Um, so here we have an example on the left. Um, this is being indicated as working for C++ 23 because C++ comes in different variants, and so you can focus on the variant you're interested in. So this is a feature that has been introduced recently in C++, which is what are these called these multi-index transformations, array references. So the idea is if you have an array that currently is expressed as three separate indices, then it can be written in this more natural notation this way. So yes, maybe this is not actually written in the best way I would have thought, but if we have some array that called A that we would like to transform, then we can express it like this, and A will probably have some three different indices. They might be actually arbitrary expressions. So you can have basically these rules are in two parts. We have some meta variables. So these are the things that we want to abstract over. So we will allow, for example, any um, expression. If this had been defined properly as an expression meta variable, we could have say expression I, expression J, expression K. And then this transformation here would apply to any expressions. Um, so any references to A. So A of 0, 1, 2, 3, or something like that, anything. Um, and this will then can be applied across your entire code base to change all of the references to A. So this is just a very simple example. Coccinelle also offers another feature that I would just like to highlight without going into a lot of detail. We have this notion of dot, 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 and dot, dot, dot means anything at all. So you think of dot, dot, dot as a kind of natural way that you would explain something to some other person on how the transformation should be performed. We care about some parts, and then some other parts we don't care about, so we say dot, dot, dot. But in Coccinelle, it's actually a keyword, and it means that whenever you have a pattern that looks like this, or we can start up here, whenever we have this Boolean result variable being declared, then somewhere afterwards, but along all control flow paths, we arrive at a for loop, and so on. So you can describe patterns not in terms of just single AST is replaced by another single AST. You can have some fragments and then describe some random stuff that is connected by control flow path, and then some more specific fragments that you want to search for, and so on. So these control flow paths will naturally jump over go-tos, around ifs, over around loops, and so on, for lots of flexibility. So Coccinelle has some other features. It has integration with Python. It has its own heuristics for managing macros, and so you can write your transformation rules in terms of macros and not in terms of what they expand into. The main important features, though, are that it gives us a readable, easily debuggable transformations way of expressing transformations. These transformations can also be used as documentation to provide to other people who need to look at your code and look at your changes and understand what has been done. In contrast to many other approaches, there's no need to learn any kind of internal representation, any abstract syntax tree, and so on. Everything is expressed at the code level. So please come and see our poster in the poster session, and we can tell you more about Coccinelle and answer any questions. Thank you.